Hi and welcome. Today we're going to talk about encryption and hashing. So this is a very difficult topic and a very long topic. So what I'm going to cover today in this slideshow, in this lecture online, is only going to be the very basics of encryption and hashing. If you're a programmer and you're going to use encryption or hashing to your project, this video will definitely be some sort of benefit to you. Alright, so let's begin. The overall agenda will be a basic understanding of cryptography. We're going to talk about something called CBC and ECB. Then we're also going to talk about why we hash our data. Talk about bcrypt, scrypt, and PBKDF2. So different kind of hashing algorithms. So the basic understanding of cryptography. Alright. So the really first and very basic introduction to cryptography that I can give you is to talk about that encryption is something that can be decrypted, right? So think about that you have a message, let's say hello, with the letters HELLO. If you encrypt that message with some sort of key, let's say you use the key of 1, 2, 3. In basic terms, let's just accept that for now it will rotate the letters 1 and the 2 will rotate the letters 2 times, and the number 3 will rotate the letter 3 times. So the H will become the letter after H, and the E will become the 2 next letters in the alphabet, and so on. This is a very bad encryption algorithm, of course. However, it kind of proves the point that you can go forwards and backwards if you know the key to your encrypted message. Hashing, on the other side, is quite different, but not all the way. It is a one-way hashing, you call it, or one-way encryption. So basically you encrypt the word hello one time, and what you get is kind of something you cannot reverse back to the original clear text hello. So clearly encryption does have one purpose and hashing has another purpose. So let's talk about hashing in more depth right now. So when talking about hashing, there are different kind of terms we should talk about. The first one is called non-reversibility. So what I just told you about a hashing algorithm or the hashing function, or just hashing in general, is a one-way function. So you can encrypt one way the word hello, and what you get is not something you can use to go back to the original message. So you might ask the question, so when you encrypt something, you will get a key. Well, that is true. So when you hash something, will you also then get a key? And the answer is no, you will not get a key. So that is why you cannot go back to the original message. Also, the function or the method, functionality of hash is not created to be reversible. Diffusion, also called the avalanche effect. Basically, it means that whenever you hash something, let's say you have a password called hello, which is really bad, but let's just assume you do have. Then you change that password just slightly. Let's say instead of HELLO, you do HELLOO, so you have a double O in the end. Now, it's very important that if you do that, you will get a totally different result from the hashing function. So there's no way of guessing what the other hash is. So if you have one text called hello and the other text called hello with double O in the end, it should give you two different, totally different hashed, or let's for simplicity's sake called one-way encrypted mishmash messages length should be around, depending on the algorithm, all from 30 to, well, into the hundreds, depending on what kind of hashing algorithm you're using. Determinism. A given password must always generate the same hash. So basically, if you do use the same hashing algorithm and you hash the word hello today and you hash the word hello tomorrow or a year later, it will always give you the same hash. Now, this is a very interesting thing because this gives you a particular purpose for hashing. Now, let me just open the lid a bit. Have you ever tried to do something called checksum calculation? Have you ever calculated a checksum for something? A checksum is something you calculate. So you say, this piece of software that I download, when I get that, it should be exactly the same as the one online I picked. So the guys online created the checksum value, which is a long string of weird letters, and you can take that and create exactly the same checksum with the algorithm given from them. And if you get the same checksum, basically it's the same as saying this 5 GB file is the same as the 5 GB file that I got. So you should be really calm now that the file you downloaded is exactly the same as the one on the web page. Basically that means that there is nothing new implemented in it, and it shouldn't be containing any bad things, basically. If you trust the vendor, of course, that is the case. For hashing algorithms, determinism is really important because you're going to use your hashing algorithms for storing mostly passwords as a developer. Collision resistance. Okay, so because this is just a mathematical representation, an algorithm is, basically it means that one particular word like hello and another word, let's just for simplicity's sake say the word cat. So the word cat and the word hello could in theory give the same result with the hashing algorithm with output. That is really bad, and that is called a collision. So a good hashing algorithm should have a really good collision resistance. Non-predictable. The hash should not be predictable from the password. So think about if you hash the word hello, in no way should you be able to hash hello, hello, hello as another string and see some sort of similarity in the two different hashed output strings. So that is what non-predictable stands for. Okay, so let me just show you diffusion because it could be a bit abstract. Think about that you have some different inputs like fox, or the red fox jumps over the blue dog and so on. And then you can see that the actual output here are some hexadecimal, it's only hexadecimal notations. So letters from A to F and numbers 0 to 9. Alright? So the actual digested message from fox will be like all of this. So let's look at the red fox jumps over the blue dog. Then you get something like this. If we change the letter V here to the letter U, which is the only change there is to this text here and there, you will see that the digested, which is also a way of saying the output or the result of the hashing method, is totally different. Look at the 2 bytes here, 0086 or 46BB. Are there any similarities here? Of course, a letter or a number could be the same, but that's not really to worry about. It's more like you would probably expect the first 5 collections of bits to be the same because it's the same text, but that is what diffusioning is all about. It should be totally non-predictable. Collision is this one that I talked about before, that you have the same 2 different kind of inputs, and you get the same hash. So that would be the actual result of the hashing algorithm. This is just horrible, and you should always be aware that if you're using a new hashing algorithm, please read about the collision amount. But not to fear, I have a really good solution to which algorithm you should use in your project. Alright, so non-reversibility is kind of just this. If you have a text called ABC123, for example, and you use some sort of hashing algorithm to hash it, let's just assume it's a SHA-1 because that is one of them. You get this, you shouldn't be able to go back as the text or the image shows, sorry. Alright, so the overall overview of a hashing algorithm is that you have some input, and it could be like any kind of arbitrary data. I'm feeling lucky. It's being filled into this funnel. It's called a hashing function, and what comes out is an output message and should be the pure gibberish of something you do not understand. Very important to understand that every hashing algorithm have the same fixed length as output string. So let's talk about encryption now. Alright, so encryption also have some different kind of terms called cryptography terms. And the very first one is the encryption and the decryption. That is the first two easy ones to understand, which I kind of already explained. Encryption is when you take the actual encryption key and you apply that with the text or the data you want to encrypt to the hashing, the encryption algorithm, and then you encrypt that using that key. The decryption process is just reversed from the encryption, so nothing to spoil there, right? The actual key is a secret like the password, and that is what I call the key. Okay, so steganography is kind of in between. Has it anything to do with the actual encryption part? Well, in some ways it does. However, I just want to mention that this is an actual science of hiding information, and you can hide information in images or streams or movie files or whatever file basically you have on your file system. So in some criminal, wouldn't call it business, but for simplicity's sakes, let's just call some criminal businesses, illegal businesses, people do hide their image. So it could be a lovely kind of, let's say, a tree image with some flowers and the sun and a deer, right? But then you could apply a key to that image, and behind that image there is another image, for example, and you can, extract from the other image. That is something called steganography. Alright, so let's talk about types of encryption. You have the first one called symmetric encryption, which is basically that you have one key, the same key you use to encrypt and decrypt, and the image kind of just show that. And something called asymmetric encryption. And basically it's this is a simplified image, but you use the sender's public key and you use the receiver's secret, which is also called the private key, to encrypt a message. Basically means that both the sender and the receiver have a pair of public and private key. So one public and one private key for the sender and the same for the receiver. And if the receiver wants to send a message to the sender, well, it's just reversed. Then the receiver use his or hers public key and his or hers sender's secret or private key. It is really easy. However, it's difficult to understand if you are new to cryptography. HTTPS or TLS, or in the older days, well, not that old, but in the past days, SSL encryption is one way of talking about asymmetric encryption. So if you want to look on a video on how HTTP works, I kind of suggest you look at this video. So it will give you a really good understanding of how the S for secure will work when it comes to asymmetrical encryption. There are some differences, and the all differences is that the symmetric encryption uses a single key and needs to be shared among all that's gonna be able to read whatever encrypted message you have. And symmetric encryption is a very old technique, and asymmetrical is kind of new. Asymmetric encryption was introduced to combat the actual problem of having one key that could be used to encrypt and decrypt all messages. And asymmetric encryption takes relatively more time than symmetric encryption. So that's the overall differences. It's something you should probably read a bit on in the text here, please, to understand further. Alright, so talking about symmetric encryption, I talked about something called CBC. It's called cipher block chaining. This is one way of thinking about encryption, but basically all this looks, I would guess, a bit difficult to understand, but think about it this way. When you encrypt, let's say, a whole message, it's in a computer, it is divided into smaller chunks, also called packages or data chunks or byte arrays or whatever word you're gonna give it, whatever kind of person you are in the IT business. Every bigger message that is more than a few letters is divided into smaller chunks, and in this case we can talk about cipher block chaining. It is kind of the word block chaining you should think right now. So the plain text here in 1, 2, 3, let's just assume that this is, it's a fly, go away. This is a 1, 2, 3, 4, 5, 6, 7, 8 letters long plain text, and you have 3 boxes here. So let's say 24 letters of text, just for simplicity, is going to be encrypted. So it is divided into 3 chunks, and the very first chunk of plain text is initialized with something called the initialization vector, or the IV, which is also used as using a key just down below. And those two are generating the cipher block encryption, which is also called the ciphertext. Now this is the actual encrypted text, and that encrypted text is used as a key to the next chunk, and so on and so on. So the only thing that's different from the very first time you do your blockchaining encryption is that you need an actual IV or initialization vector, which is just some cryptography generated key. Not something you generate yourself, it is something that is being pre-generated for you in most cases. This is a particularly slower version of symmetric encryption because you need to know the very last package to decrypt the whole thing. It is why it's called chaining. Think about it this way: you have a lot of chains and they are interconnected because the one before used that, encrypted text to encrypt the next, to the next, to the next, to the next. So if you don't start from the end, you will never get the original text back. You have to start from the end. If you start in the middle, you will get nothing, because let's assume that you want to decrypt from the middle here. You will need to use the key that you got from this one, but you don't have it. So that's an issue. Alright, so I have some code here if you want to use it. It's a CBC example. Pause the screen, write the code. I'm gonna proceed now. This is the other part of it. Pause the screen and write the code. Alright, so let's talk about ECB symmetric encryption. It's a bit more easy. Now that you understood the cipher block chaining, you're going to talk about the electronic codebook mode encryption, ECB. You have a key, You use it for some plain text chunk, and you use the same key again, again, and again. So basically that means that if you don't have the whole message, you can actually try and decrypt it even though you don't have it all. And you can start from anywhere, like in the middle or the end or whatever you're gonna do. So that is a lot more easy way to encrypt and decrypt. It is also faster, and it is not as secure as the other one. Bear in mind that these two different kind of algorithm called CBCs for cipher blockchaining it's a symmetric encryption, and the other one is also symmetric, so it is not asymmetrical as I talked about earlier. I also have an example of an ECB part of code here. Please look at this Java code geeks.com, and you should find a really easy example to try out. Alright, so why do we hash our data? This is the next question we're gonna talk about. Now, you will never store clear text in the database. It's a stupid idea, and it should never be used. So you hash your clear text data like passwords. You shall never, thou shall never use non-HTTPS connections. It is just as unsafe as sending clear text using HTTPS. So always hash your passwords, use your HTTPS connection. In case of leak or data of hashed, well, if your data is leaked in some way and the hackers or whatever I'm gonna call it is in possession of your hashes which contains passwords, it's really important that you have a good incident response plan. How are you going to recover? This is not something that I'm going to talk about right now, so just to say that at some point I'm going to post a video about incident response in more depth. Well, then by all means I suggest you watch it to get a really good idea of how to handle that kind of strategy in your company. So different kind of hashing algorithms, bcrypt, scrypt, and PBKDF2. So the bcrypt is the older one. It is 20-ish years old. It still rocks, and it is still the favorable one to use. I have a source down here in the cheat sheet series to the OWASP.org webpage, where you can read about in more depth password storage cheat sheet, and it applies to multiple different languages. If it doesn't have your language, the cheat sheet from this webpage will definitely still help you a lot. Bcrypt is still the hashing algorithm you should be using, and it is still the one that is the safest one that we can prove at the moment that is the safest one. Scrypt is probably the better choice if we look at the research going on at the moment. However, I haven't still heard it to be recommended over the bcrypt. And that is also something you can read about on the OWASP cheat series if you get that far. So the scrypt algorithm is designed to use a large amount of memory to compute efficiently. Alright, so that is really good when you want to create the hash, because it takes a long time for the computer. Basically means that if a hacker got his or her hands onto the amount of hashes you have in the database, it will take that person a longer time to decrypt them. Well, you cannot decrypt a hash, but you can save all hashes with the letters of 1 to 16 characters and download something called a rainbow table, which is just a large file containing all passwords pre-hashed already, so you can just compare the hashes and then it's that clear text. So it's the reverse method. It's guessing, but it's not really decrypting. The purpose is to make it harder for those who have our hashes to crack our hashes, which is the word you use when you have a hash, you do not decrypt it, you crack it, right? The PBKDF2, which is also really difficult to say 10 times in a row. It's been out for a long time, and yeah, it's been for a very long time. So I would say that I am no cryptography person. I know enough to pick bcrypt because that is what the documentation tells me to do. OWASP tells me to do it. I'm pretty sure SANS courses tells us to do it. But nevertheless, or even the NIST standards. So I would suggest that you still use the bcrypt algorithm for now. So there are some different things we can talk about when it comes to versuses, bcrypt versus scrypt. Scrypt is supposed to be better. I would really like to see scrypt, being used at some point, but I also see some weaknesses in it that I haven't really. Well, it is not my field, so I hope they make it useful at some point. What it haven't been receiving is a word called scrutiny, and it is basically what we call critical observation or examination. It is something researchers do, people that research in cryptography. I am not a person that does that. I use documentations and I understand them and I know when to apply, and basically we need to understand that this is the way to go. Gonna trust the researchers at some point, right? There are many different kind of hash table comparisons you can find on Google, and this is one of them, and I wouldn't say that it's a really good one, but I haven't really found a good one that is like really, really good. But look at it and give it some thought, Don't pick the scrypt, even though that it kind of looks like it's really good. That you need to spend $900 to crack something which is only 6 letters, and spend like only $1 for bcrypt. So it basically means that using scrypt is just a lot more heavy and intensifies the compute power a lot. But for now, stick to bcrypt, and that's about it. Also have an example of bcrypt here you can use. It's all on GitHub, and you can also use CrackStation to try and crack hashes to look for basically just understand how easy it is to crack a hash. So if you want to read some extra stuff, you can read about the AES or ECB mode, and it's all the website called Quora or or something like that. I cannot even say it. So I hope that you liked this video about encryption and hashing. It was only introductory and I only gave you a few steps in the sand. But I want you to understand that encryption and hashing is not something you should be looking at lightly. It is a very deep topic. It is an intense topic, and there's a lot of work to do there if you want to have a really good understanding. What I suggest you do if you are a developer or you are into the IT business, stick to the idea of using the algorithms that is being taught by the official documents like the NIST standards or the OWASP standard. Alright? So see you again online, and please subscribe, like the video, and comment if you have any questions. I will most definitely reply to you. Bye.